Hi everyone, welcome to a presentation on the grasping glove, in which we use shape memory alloys to increase grip strength for users with RSI. My name is Adit and my team is Janik Silva, and we are group 10. So first, what is RSI? RSI is a general term standing for repetitive strain injury, and it's used to describe the pain felt in muscles, nerves, and tendons caused by repetitive movement in obese. Our user has carpal tunnel syndrome, which is caused when the median nerve in your wrist becomes squeezed or compressed. Often, the treatments include using splints, ultrasound, and heat to reduce the pain and reduce the strain. The symptoms of carpal tunnel and RSI are decreased grip strength, dexterity, pain in the wrists and joints, and can be affected by the angle of the hand during repetitive work. So when we came to make a solution for this, we wanted to treat the issue at its root, to develop a device that could be generalized to everyday use. So our solution was to create a glove that grasps for you. Current technology involves using external joints and loud, heavy actuators to manipulate the hand. Our idea and our solution is to use neither of these. We hypothesized that using nitinol wire, which is a shape memory alloy, which means that it is a temperature dependent material and it changes shape when a heat or current is applied. Therefore, by compressing, it can apply a force on the tendon. So our hypothesis is that using nitinol wire as an actuator will allow for efficient and silent operation to increase grip strength. These are our first few sketches and first few prototypes of our system. The general idea is we have a spring that is connected to power. One end of the spring is fixed, and the other end of the spring is connected to a tendon made of nylon string that is fed through a series of hoops that can act like a tendon and actuate your joint. In doing so, we make it very universal, as this could fit any person, and it doesn't depend on their joint angles. And this is a video of our first prototype in action, showing how when heat is applied to the current, the spring compresses, heats up, and pulls my finger forward. So based on this first prototype, we wanted to improve the idea and make it more well packaged and more of a final polished product. So this is our final product. On the left, we have a black 3D printed part, hollow tube, that all the wires can be fed through to keep them nice and clean. And it straps onto your wrist. And on the right, we have the glove that the user can wear. The tendons are now made of nylon using strings to wrap them up in hoops. And we also have a force sensitive resistor, the FSR, that can detect pressure and detect when you're trying to grasp. And by doing so, you can create a closed loop system for actuation. Another improvement from our first prototype is that we now have 2 ground wires and 1 power, which you can toggle on and off. What this allows us to do is use one spring as both something that can compress and pull the string forward to close your wrist, or it can turn the other ground wire on and relax the finger so you can open your wrist. We found that this was very important to add, as it allowed for increased functionality and ease of use for our user. Here is a video of our product in action at the demo. Over here, you can see that my FSR detects a grasp and it starts heating the spring. When it heats a certain temperature, the spring compresses and moves back. And now I'm demoing how I can lift the sponge without any external force from my fingers. This is entirely actuated by the spring. So what were the overall results? We found that nitinol wire does have a potential to be a game changer in actuation technologies. It is very silent and has quite a bit of force, especially if designed properly. Although more work needs to be done to make it slimmer and to deliver power faster. An issue we had is that using batteries wouldn't heat up the wire fast enough. So using thinner, smaller wires with a stronger battery could be a solution. And studies need to be done to see if multi-finger grasping can be achieved by having multiple nitinol springs attached to each finger, which would allow for more range of motion and a more completed system. Thank you for watching.